Hi and welcome to our next video on the area of composite shapes. Alright, so if we have a look what a composite shape is an irregular shape that is made up of other shapes, or if we look at the word composite, composed of other shapes. If we have a look at the example here, you can see we've got a shape here. It's a house shape that's composed of a square and a triangle combined. You can see with this line put in here that it's actually composed, that it's combined the two shapes to make that house shape. If we're looking to find the area of these shapes, what we actually need to do is we need to break them down into those shapes and then calculate the area of each of those shapes separately, and then either add them together, or depending on how we're actually going to calculate them, we may need to subtract some areas there. But in this case, you can see we've got our we've got our triangle here and our square here. What we could do is literally we could have these, we could have area A here, area B for the triangle, and we could actually calculate that the total area equals the area of A plus the area of B. You could label these with anything. You might label that with triangle and square, so that would equal the area of the square plus the area of the triangle. It doesn't matter, you could label them 1 and 2. We generally would label them to break them down into the smaller parts. Now, when we look at some composite shapes, sometimes it's actually how we see the actual breakup of that composite shape might be different. So you can see here, if we've got this shape, which is almost like a U shape there, you can see that breaking that down into the smaller shapes for that shaded area, we can look at it two ways. Here we can actually look at the break it down into rectangles. So we've got area 1, 2, and 3. And for this total area, it would actually equal area 1 plus area 2 plus area 3. So we'd add all of those up for that shaded region. Sometimes we can actually see it as a larger rectangle. You can see this larger rectangle here with this piece missing. And in this case, area 1 is the whole rectangle, and area 2 will be the small bit cut out of it. So if we're looking at this, the total area actually equals area 1 minus area 2. So we're actually taking the unshaded region out of the shaded region. So depending on how you look at the shape, you might see that it's easier to add them together. You might find that some parts you actually need to make a bigger shape and then subtract the empty space. How you do that really determines, it's up to you. In most cases, it'll be quite distinct on how you might need to do that. Alright, so I guess some little steps for success to actually finding the area of these composite shapes. First of all, we want to draw the diagram of it. That's really simple. We just want to get that diagram drawn so we can actually see it visually. Then we want to split that up into those simple shapes. So like we just did there with those shapes, so we split that up into the simple shapes. We then need to determine any unknown measurements required to calculate the areas of those shapes. So if we've given dimensions and there's some that we don't know, we need to determine what they are, any unknown measurements. We also want to label. We then want to label those newly formed shapes. So make sure that we've actually got them labeled, as I spoke about just before. We're then going to write down the formula for how we're going to calculate the total area. So, area A plus area B plus area C, whatever it might be with the question that you need to answer. We're then going to substitute and calculate the area for each of those simple shapes. So we'll do those separately. And in the last step, we're going to calculate the total area of the composite shape by doing the calculation with those areas. All right, so we'll have a look at some examples. The first example, we've got our house shape. Now, if we have a look at our diagram, we've got our diagram here. You can see that we've got some information. The one thing that we don't have is all that we need to determine is, well, if we break this shape up, we've got the square and the triangle, is we need to determine the height of the triangle for our formula. Now, if we have a look at the information, that the height of the square is 10, and the total height of the house is 18. So this vertical must actually be 8 centimeters. All right, so we can actually put that in, 8 centimeters. Now what we can do is we can look at, okay, well, my total area is actually going to equal, now I'm going to label the square A and the rectangle B. So that's the area. Okay, so let's start with area A. The formula for that equals length times width. So area A, so that's going to be, if I substitute that in, that's going to be 10 times 10. That equals 100 centimeters squared. Area B is a triangle, so it's base times height divided by 2. So that actually equals, well, the base is 10 times 8, which is the height, divided by 2. So that's 80 divided by 2. That equals 40 centimeters squared. So now the total area, that's going to equal area A plus area B, so that's going to equal 100 plus 40, and that equals 140 centimeters squared. All right, the next composite shape we've got here is, it's a strange looking shape. We've drawn the diagram, we can see we've got a couple of shapes, and I can sort of see that we've got a rectangular type of shape and this semicircle. Now for this area, what I would actually do is I would actually bring a dotted line just down here, and I'm going to make the total shape, so the shaded area is going to equal the large rectangle minus this semicircle. So I'm going to have the total area, or the shaded area, equals the area of this rectangle. I'm just going to put area of the rectangle minus the area of the semicircle. All right, and I've labelled those with the words rectangle and semicircle. All right. 36 meters squared. The area of the semicircle, that actually equals, now the diameter, so we've actually got pi times radius squared divided by 2 for a semicircle. Now because we know the diameter is 4, the radius for that should actually equal 2. So the diameter equals 4, so our radius actually equals 2. Therefore that area equals pi times 2 squared divided by 2. That equals, if we get our calculator out, get 6.283. So 6.28, so that equals 6.28 meters squared. Okay, therefore, I'm just going to come over here. The total area, or the shaded area I should say, equals 36 minus 6.28, which equals 29.72, oops, not centimeters, meters squared. So you can see for the first one we added the two shapes together. For this second one we've actually calculated the larger shape, and we've subtracted we've subtracted that semicircle out of that shape to get the shaded area. Alright, thank you for watching that. Hopefully you got something out of that, and we'll see you in our next video.